Coming to Newton laws, first we can understand Newton first law. First law The first law is the law of motion. A body at rest will remains. A body at rest will remain at rest, and a body in motion will remain in uniform motion unless acted upon by an unbalanced force. So this statement can be stated in another form, another way. A body remains unaccelerated if and only if the resultant force on it is zero. What we can understand here, suppose this is the object, myself, this is the okay. So this is the, you take it, this is the object. Obviously it has mass, obviously it has a weight, it has a mass. So it is put on this surface, unless otherwise there is a force act on it, this object doesn't get into the displaced, or doesn't get into the move. So this is called law of motion. Another way, in case suppose if you apply a force on either side, the statement the body is in motion will remains at rest. Of course, if you apply a force here on this object, let us say that 12 newtons. In this direction also you are apply a force 12 newtons. So because you are applying the same magnitude of force on either side, so that again this object is remains in the rest condition. So this is called equilibrium. This is also satisfies the statement of the law of motion. It is in the stationary and rest condition. Even either side the same magnitude of force is applied. Okay, that is also satisfy the law of the motion. In uniform motion, another condition also, suppose there is an object or some other some vehicle, that is the vehicle is moving with uniform acceleration on the road or same velocity. Let us say that v is equal to 2 meter per second velocity. It is moving with the 2 meter per second velocity with respect to time, no change. That means no change in the acceleration. The acceleration is same, uniform acceleration. So unless otherwise the external force is acted upon on this object acceleration is not increased. That acceleration is not increased. That means velocity is not increased. That state is also called law of motion. Of course, what we can understand here, when the object in the stationary condition, that is called law of motion. Satisfies. Another condition, so an object is object is moving with uniform velocity or uniform acceleration, uniform velocity with time, with respect to time, or uniform acceleration, that state is also satisfies the statement of the law of the motion. Suppose there is external force is acted, then only that object motion, the velocity or acceleration is changed. This also satisfies the law of the motion. So a body remains unaccelerated if and only if the resultant force on it is zero. Another condition also you can know. Another example is also take. We can take. Suppose. So okay, this is the vehicle is there. So this is the vehicle. You applying in this force. In this direction. 15 newtons, 15 newtons, uh, 15 newtons. Suppose this force is, of course, let us assume this object is moving like this, moving like this, moving like this, moving like this. The force is you are applying 15 newton force in this side also you are applying 15 newton force. So even though that object is moving with the same velocity, before the forces are applied at the either side, that object is moving with a certain acceleration, even you are applying this same magnitude on either side, thus the original acceleration that object is moving, that is condition is also satisfies the law of the motion. What we can understand, this resultant force on it is zero, resultant force on it is zero. I have already explained, this is the force is acting, this object is moving before the force in either side, same magnitude of force is acting, that object is moving with certain acceleration, certain uniform acceleration, let us say that 2 meter per second square acceleration. You are applying the either side same force, same magnitude, that let us assume that object is moving with the same acceleration. Why? Because this side is you are applying in your 15 newton per force, so this side is also you are applying the 15 newton per force, even though that object is moving with the 2 meter per second acceleration, which is moving before applying this force, So therefore the resultant force is the resultant force or net force acting on the object is zero. How it is zero? So resultant or net force means resultant or net force means resultant or net force means the algebraic sum of the forces acting on the object becomes zero. The resultant force. The resultant force means net force or resultant force means the algebraic sum of the forces acting on the object, that is a resultant. In this case, that resultant force is zero. You can understand here. This force is acting in this direction. This force is acting in this direction. Let us say that this is the left to right. Let us say that this is the plus, right to left. This is the minus. So 15 newtons, this is the plus, this is the minus. You sum up. The resultant means the algebraic sum, irrespective of the signs, you sum up 15 newtons. So what you get? Zero. So this is the meaning of this. Resultant force on it is zero. So therefore, the motion in this object does not change. Does not accelerate. This so because of this net resultant force is zero. So this object does not accelerate. That is the meaning of resultant force or net force. The resultant force is nothing but resultant force is nothing but the algebraic sum of the forces which are acting on that object. Obviously, in one direction you have to consider the positive sign, another direction you have to consider the negative sign. Though they are supposed to be added, sum up irrespective of that signs. If you get zero, this object doesn't change its acceleration. This is the condition is also fulfill or satisfy the law of the first Newton law of the motion. The first law also related to inertia. Inertia means a body on its own does not change its state of rest or uniform motion. Of course, the inertia is nothing but what we discussed so far. That is also connected to this inertia. What is telling that? What is the statement? The body is its own does not change its state of rest or of uniform motion. The another statement, the inability of a body on its own, its state of rest or uniform motion is known as inertia. A body is in a state of rest or in uniform motion that a state of that object is called inertia. That state of object is called inertia. Let us what we can understand here. So let us assume I am the object. So unless otherwise any external force is acted upon my body, I am keep on in this position any longer time, any longer time. This is called inertia. Or otherwise I am walking with uniform velocity, let us say 2 meter per second velocity. So this velocity does not change unless otherwise there is some external force. So if I am moving with uniform velocity with respect to time or velocity, this position is also called inertia. This position is also called inertia. The same is explained in the previous statement also. Okay, the inertia is in two forms. One is inertia of rest, one is inertia of motion. What I have explained, a body at rest remains at rest. A body, myself, it is at rest in this position. It is keep on in this position unless otherwise some force is acted upon my body. This situation is a law of this is called inertia, or one type of inertia, that is first type inertia of rest. Or otherwise another one, inertia of motion. Inertia of motion means I am moving with same velocity without change of velocity. This position is also called inertia of motion. That we have to understand from the inertia. Inertia is best example. Another example, lazy fellow. Suppose some of the students or kids, they are morning, they are keep on sleeping. Even you get a call from the father and mother, it doesn't wake up or get up from the bed, he is keep on sleeping. That is the inertia. That is also example of inertia. Now we can see the relation between the inertia and mass. The statement is the heavier body has greater inertia than a lighter body. So how can we understand this? Suppose there is an object here. This is the object here. The small one. You are applying a force, F force. Obviously, this is a heavier body is there. You are applying a force, same magnitude of force. This is moving with, you are applying the velocity force. Obviously, this is the small mass is less. The mass is less compared to this one. So that it is moving with greater velocity than this one. It's greater velocity than this one. This object is moving with, let us say that 4 meter per second velocity. Of course, this is the heavier body. You are applying the same magnitude of force. The force equal to 5 newtons. Here also you are applying 5 newtons. This object is moving with 1 meter per second velocity. Why? Because this is the same magnitude of force is applied, but this is moving with 4 meter per second velocity. This is moving with 1 meter per second velocity. Because of this, the mass is heavier than this one. This mass is heavier than this one. Hence, this object heavier body object inertia is more than the lighter weight object. So that this object is moving gets more velocity than this heavier velocity. So this is the meaning of that statement. So inertia to mass, we can take so many examples. So for example, if we take a glass water, a empty glass. On this you put it a card. On this you put it some ball here, like this, some ball here. Suppose so this these both surfaces are contacted here. Obviously this force is acting in this direction because of this force is in this direction, so that it is in rest condition. So this ball is force is acting on this plate in this direction. This plate is the same magnetic force is applying in the opposite direction, then only it is in the rest condition. Suppose in horizontal direction, if you apply force and if you click force apply on this horizontal plate or card, this card is moving. Let us assume the frictional force is, zero between this object and this object in this surface. Frictional force is, let us assume, zero. If you put it a force in this direction, this card will be moving in this direction, but this ball is getting down into the glass, because in the horizontal direction the force is acting on this card only. Here there is no force acting on this in the horizontal direction, because of inertia, weight of mass of that object, these are getting in this direction because it is in the rest condition. Because it is in the rest condition. That is the one example. Another example, when we are let us assume the bus is running. We are in the standing position in the bus. So all of moving. The bus is moving. You are standing in the bus in this position. All of a sudden, the driver is applied brakes. What is happening? Our front portion, this portion is falling in frontward direction. Frontward direction. Why? The rest of the put is contact with the surface of the vehicle, and there is a frictional force, is the rest condition. So rest condition, because of the frictional force, between the surface and the surface, this is the vehicle surface and this is the leg. This is a frictional force. This is in the rest condition. While it is moving the vehicle, this is also in the moving condition. The bottom portion is moving condition because of the frictional force. It is the same motion, but the top portion it is not in the rest condition. Obviously, it is falling front. In the same way, when you are in the standing in the bus, all of a sudden the bus is started, the upper portion of our body is falling back. Why? Because the same condition is the rest condition. So the frictional force is established in the surface and the legs. All of the sudden you are falling back. This is in the rest condition. This is the moving along with the this surface, and these legs are unitedly moving, acting in the same way. Upper portion it is falling back. This is also inertia, example of the inertia. One more example, you can take carom board. The striker, if you strike, the coins are arranged in vertical manner. The striker is you apply the force. Obviously this object is this last coin is coming like this. These top coins are suddenly falling because of inertia. Why? Of course, the last coin, this force is acting in this direction. This force is acting in this direction. They are the same forces are acting in the opposite directions. So are in the rest condition. You are applying in the striker. With the striker, you are applying the force on the bottom coin. In this bottom coin, let us assume the friction is not there. So bottom coin is hit this bottom. The striker is hit this bottom coin. The coin is going in this direction. The top coins are falling down because they are in the rest condition. They are on that coin. There is no horizontal force acting. This is the rest condition, so that it doesn't get move like the horizontal coin. Because of inertia, they are falling down. These are all the examples of the inertia and mass. Obviously, what we can understand here, the mass is more, the inertia is more. The mass is more, inertia is more.